Hello everyone, this is Daily Development, and today we're going to be going over a problem that was asked by Google. So without further ado, let's jump right in. We're given a string and we need to return the longest palindromic subsequence in that string. A palindrome is a word that can be read from left to right or right to left, and nothing will change. So, for instance, let's take a word. Let's take this word right here. We can read it from left to right, and it's going to be exactly the same as if we're going to read it from right to left. They are in both cases identical. And our interview problem that was asked by Google is we're given a string and we need to find the longest palindromic subsequence. So in this case, in this word, APTM TPA is the longest palindromic subsequence, and we have to return that. So I encourage you guys to pause the video, try to solve it yourself, and then get back to me. All right, so I will jump right in. If you haven't paused the video, pause it because I'm going to show you the answer. So let's create a function called find longest palindrome. It takes as a parameter a string. Let's pass this for right now, and let's just print find longest palindrome of this guy right here. So what we need to create here, let's first create a couple of if statements. So if the length of the string is 0, and just return 0. Right? There's no palindrome here that can be created, or return none. Now, next thing that I would like to create is, other than this function, I'd like to create a second function called definition find all palindromes. And then it also takes string. So the idea here would be I want to find all palindromes, right? And then I want to loop through. I will ideally, so I want to get all the palindromes, then find whichever is highest, and then return longest, and then return that longest palindrome. In this case, let's take it. So let's take palindromes. Let's make it an empty array. And so what we have to do here is so my idea on how I want to find a palindrome would be, let's take this word, right? First letter, let's say we start from M. What we need to do is we need to now find another letter M, because what we know about palindromes is reading from left is the same thing as reading from the right to left, right? So what that means is if the palindrome starts with M, we know it also has to end with M. So in this case, when I'm going to be starting with a letter M, I also have to find a letter. The palindrome must end on M. So I'm going to, now once I'm on M, I want to find another M, and then see if that string in between is a palindrome or not. Let's write this type of script. So let's create a for I in range. Now let's make it from length of string -1. And let me show you why it is length of string -1 and not, let's say, length of string. So the idea here would be length of string. All right, so this is the reason why I want I to be from 0 to length of string -1. It's because J will always come after I. So imagine if I is the index right before the last index, right? So then J would be the last index, and so it works out. But if I will ever be the last index, then J would just go off bounds, right? So for that reason, to make sure that J never goes off the bounds, we need to make sure I will never be the last index. And in that case, that's why we subtract 1. So it's never the last character. J, so J, it's never the last character, so we give this area to J, right? So J doesn't go off the charts. So now what we do is, let's see, is the if string and I, so in other words, if that character is the same thing as J, right? So if let's say we are M is right here. If we found another M, well, that means this whole thing could potentially be a palindrome. Now in this case it's not, but it has a potential to be a palindrome. So let's check. Now let's create a third function called definition is palindrome, and it takes a string. So, well, how to check whether it is a palindrome or not? It's actually relatively simple. We need to do string equals to string double colon and then -1. So there are actually 3 parameters that string has. Let me show this to you right here. So if we let's say do string and you just put one parameter, right? 4, let's say. It'll take the fourth letter in that string. Now, if you do 4:7, it's going to get the 4th, 5th, and 6th letter of that string. So everything up to 7, not including 7. So it's gonna get 4, 5, and 6th letters. But then there's also a third parameter. So let's say the third parameter, if you do 2, what that means it's only going to get every second letter. So it's going to ignore the first letter, it's going to take the second letter, it's going to ignore the third letter, going to take the fourth letter. So it's going to only take every second letter. If you do 3, it's going to ignore the first 2 letters, it's only going to take the third letter and 6th letter, and so on, right? But if you put a negative sign, and let's say you put -2, it's going to go backwards. So for example, let's just say in this case we have -1, right? What that does is, if you give it the string, right, instead of if you just put 1 here, it's going to return the same exact string, but -1 would make it so it goes backwards, right? It's going to read it, okay, A, P, T, M, so it's going to return the string, but it's going to return it backwards. And in that case, if what we're doing here, so if this string is the same thing as, if it equals to itself but backwards, then it's a palindrome, right, essentially. So let's create a variable called a possible palindrome, and let's make that equal to a string from I to J plus 1. And I want that plus 1 because I want Jth letter to be included. So in this case, we know M, right? Let's just take I0. Okay, so then it starts from M, and J is also M, but I want that J letter to be included. I don't want to take this string right here, right? I don't want to just ignore the last letter. I want to include the last letter, right? I want to take this whole thing, this entire thing. So that's why I add that plus 1 to kind of keep that last letter. I don't want to ignore it. And next thing is, we know that this is only a possible palindrome, right? We know it starts with the same letter, it ends. But in this case, for example, what I highlighted, it's not a palindrome here. It doesn't equal to itself by backwards, right? So for that reason, now we have to check. Now let's check. If is palindrome, and then let's put possible palindrome here. So if it is, right, if we check, then now it is, let's add in the list of palindromes, append possible palindrome. So now, in this case, it's not palindrome. Now we know it's a palindrome. So add it, right? Now at the end, now that we have the list of palindromes, let's just return palindromes. Right? Now what we need to do is, first thing is let's make all palindromes. Okay, and there's something I would like to do. So if length of all palindromes equals to 0, then we have to return 1. And why 1? It's because you can always get a palindrome of length 1, right? For example, let's just take M. This is a single letter. This is already a palindrome. If you take one letter, you can read M from left to right and from right to left. That would be essentially the same thing. So for that reason, I would include 1. You can't get lower than 1 unless just string doesn't, unless it's empty, right? So if string is empty, okay, then it's really 0. But otherwise, like for example, we could return, string, let's say 0, the first character. Let's say that's already a palindrome of length 1. All right, so now what we have to do is let's create a for I in range, and then from length of palindromes. Or actually, let's make it this way. So let's make the longest let's make this longest palindrome, let's say equals to 0. And then here we start from 1 to length of all palindromes. And what we have to do is now, if length of all palindromes longest is less than the length of all palindromes of I. So the idea here is we're trying to find the longest palindrome. We are first saying, all right, let's just take the very first palindrome, right? Let's take the 0th index. Let's say that palindrome is the longest. And now, starting from 1, see if there is any other palindrome that is longer than the very first palindrome. And if we find it, let's say the length of all this palindrome is less than a certain palindrome. If we found it, then let's make so then longest equals I, because we know that the ith palindrome is longer than this the longest palindrome, right? So now we have to reassign it. So after that, what we have to do is we have to return all palindromes longest. Now if we run this, so sorry, there was a mistake in the I guess instructions. This palindrome is the longest, right? Because APT MTPA is actually not inside of this, right? It's so this guy right here is not actually a palindrome because it has the PNM, right? So in this case, it's off. It's not a palindrome. So this guy is a palindrome. This is the longest palindromic subsequence in this string. So I mean, it's working now. So we finished this Google interview question. If you have any ideas, if you solved it in a different way, right, and you would like to share your way with us, please put it down in comments. I would love to see that code. And put thumbs up if you like it. And see you next time.